Today we're going to look at systems of equations, section 8-5, and this is going to give you a little lead in here. Basically what we're looking at is two lines and where they cross. Okay, so system of equations is two or more equations in the same variable. So basically it's two lines like we've been graphing. Okay, that's our system of equations. The solution is going to be values for variables that make a system of equations true. So back here, if x equals 1 and y equals -1, these two will then be the same. They'll have the same values. You can also think of it as an ordered pair. Okay, that's your solution. So you can do these a couple ways. As I mentioned, we could graph them, which is what we're going to focus on today. We could also do this algebraically. Okay, so there's two methods. We'll do algebraically first. If you remember, we did this way back in chapter 5. All right, it's when we substitute one for the other. If you remember, we take this, and if x minus 2 equals y, then I can take this whole thing and put it in place of y. Okay, so instead of y, I write x minus 2, and then I bring down my rest. And then I'm going to solve it for x. Now I just have one variable, so it's solvable. And I keep going until I get x by itself. So x is 7/3 or 2 1/3. Okay, so that's the first part of my ordered pair. To figure out what y is, I just plug x back into either equation. Well, obviously the top one's a little easier to do in your head. If x is 2 1/3, then 2 1/3 minus 2 would just be 1/3. So that'd be my y. Okay, so algebraically works well, especially in a problem like this, when it gives an exact solution. Whereas if I graph those two lines, okay, so let's start with 5. And then I go down 2/1. Okay, make sure you make it long enough, okay, so that we can figure out where they're going to cross here. You don't want to leave it too short and then have to redraw. I'll also get you some rulers so you can make nice straight lines. So this one starts at -2 and goes up 1/1. So you can see where they cross. If I draw my line again. Okay, so you can see here, this is the same system. Same solution, it's just not as easy to tell exactly where they cross because they don't cross at a nice intersection like -2, 1. Okay, here's your 2 1/3, 1/3. So same system, solved two different ways. All right, so let's try this one. Top one says it starts at 2, and oops, let's make that one blue. Starts at 2, and my slope is 0.5. Of course, 0.5 is equal to 5/10, which is 1/2, so I can just go up 1/2, or down 1 back 2. Draw myself a nice straight line. Okay, and then for 0.5, let's see, that one's going to start at the origin, and it's also going to go up 1/2. So what does that do for us? Well, looks like we've got two parallel lines. Okay, so basically that means we have no solution. They will not cross because they're parallel. Okay, let's try this one. We've got y equals 1/2 x minus 3. So I go 1, 2, 3, up 1/2. And again, we don't know where they're going to cross. So we'll make it 21. Draw our line. Okay. This one starts at the origin and goes up 1/1. Well, clearly they're not going to cross this way, so I've got to go back this way. And it looks like they cross right there. So we draw a nice straight line. Okay, and then we can see where they cross. Well, it looks like they cross right here. So our solution would be -1, 2, 3, 4, 5, 6, -1, 2, 3, 4, 5, 6. Whoops. So my solution is negative 6, negative 6. Okay, and also, if we wanted to check ourselves, we can see this works, but you could always put negative 6 back in here for x and in for y, and we're going to get the same thing. Well, negative 6 obviously equals negative 6, and half of negative 6 is negative 3 minus 3 also gives me negative 6. So we can prove it both ways, algebraically and graphically. So without graphing, tell whether each system of equations has a solution or no solution. Okay, well we just learned that if they have the same slope, they're going to be parallel and therefore have no solution. So let's look at our slopes. Well, these two have different slopes. We have a half and negative 2. That means that they will cross somewhere. These two both have slopes of negative 3. That means they're not going to cross. There's no solution. And this one I wrote in a different way, but you can still tell that both your slopes are negative 5. That means that they won't cross. There's no solution. But what if they're in standard form? Well, there's no real quick way to do that. Like on this one, we can't just look at the slopes because we don't have any slopes. So what we can do is we can then solve them for y, put them in slope-intercept form, so then we can compare the two slopes. So let's go ahead and do that. So we subtract 4x. So y equals 2/3 minus 2/3 x for that one. And this one, okay, so again, all we have to do then is look at our slopes. Well, in this one, my slope is negative 2/3, and in this one, my slope is negative 2/3. That means they will not cross because they are parallel, so there's no solution. Okay? And if we were to solve this one graphically, we want to figure out where these two lines cross. So let's start with the first one. Let's see. Well, when it's in this form, remember we can do one of two methods. We can do what we just did here, solve it for y and then graph it, or we can also do the method 2, which was to find the x and y intercepts. So let's do, I don't know, it doesn't matter. I was just going to say let's do one of each, okay? So let's do the solving for y in this one since we just did that twice. So it'd be y equals 5 minus 2x. So it starts at 5, and then I go down 2 over 1. Okay, draw myself a nice straight line. Go. All right, and then for the other one, let's do method 2, just to remind you what that looks like. That's where if we cover up 1, okay, so then my x-intercept would equal 4. Equals 4, so 4, 0 is my x-intercept. And then I say, well, also the negative y would equal 4. Well, I have to divide both sides by negative 1. So y is negative 4. So 0, negative 4 is my y-intercept. So 1, 2, 3, 4. And then 4, 0, 1, 2, 3, 4. And then we'll draw our line. You can kind of see where they're going to cross there. Okay, this is where you need to be nice and precise. We need to figure out exactly where these two lines cross. And they cross at 1, 2, 3, negative 1. Okay, that's what we're looking at.